Okay. Okay. Okay, we're ready. Quiet, please. Quiet. Okay, we're going to get going. Um, Today might seem like we're departing a little bit. It won't seem very familiar with the things we did in the first two lessons, but it will come back around like next class, and you'll see why do we start then doing these things with matrices. Have you had any matrices in the past? Anybody? A little bit? How many say never had matrices before? My guess is a lot of you wouldn't because it's been dropped from the Algebra 2. I don't think they do it in Algebra 1. So in any case, it used to be like a really standard part of the curriculum, and now it's not. So we're gonna go over some real basics about what's a matrix and things like that, and we'll learn how to do basic operations with matrices, and that's about it today. 19 slides. We'll see. Now remember, most of these graphics are in your textbook. Please don't write down every little scribble on the screen. I mean, we'll be here all day. The definition of a matrix is always considered a rectangular array of numbers, right? Meaning it's got a certain number of rows and a certain number of columns, and most of the time when you see it, it's got square brackets on the outside like that, right? Notice how on the left here, right, it's counting down the rows. 1, 2, 3, and the last row is M, right? So there are M rows, and the columns are going across like this, 1, 2, 3, and the last column is N. So there's N columns, meaning we'll fill in the M and the N in the end. We're not dealing with indefinite number of rows and columns. N columns. Right, so there will be M times N numbers inside the matrix. Those are called entries. Right? Each one is called an entry. And if you notice, the entry is usually it's written with a lowercase letter. If the matrix is defined as a capital A, which is common, then inside it's a lowercase letter a, right? And you notice how when you go down the rows, right, then the first number is changing, but the second number stays the same. So you read this literally, this is first row, first column, this one is second row, first column, this one is third row, first column. Okay? As you go across, you're going first row, first column, first row, second column, first row, third column. Right? A32 is the entry, third row, second column. Okay, so the order, right? The order of a matrix is the number of rows times the number of columns. Not meaning you're going to multiply those together. You're going to write it like the number of rows, and then you write the X like a times, and then number of columns. So these are their examples, right? For the first one, how many rows and how many columns? There's one row and one column, so the order is 1 by 1, 1 by 1. That's how you write the order. And if you had this before somewhere else, they might have used the term dimension, because that's actually what I'm more familiar with, calling it the dimensions of a matrix. But it's the same thing, order or dimension. Right? This next one here is how many rows, how many columns? 1 row, 4 columns, 1 by 4. How about letter C? Yeah, this one's easy because it's the same anyway, so you would just say 2 by 2. But the last one, there's a difference. How many rows, how many columns? 3 and 2, so you would write it like 3 by 2, right? How about the one down here? 2 by 3. 2 rows, 3 columns. So just that little piece right there it comes from the very first page of section 8.1. Most everything else we're doing today is coming from section 8.2. Okay, usually we use capital letters to represent the matrices, right? And usually it starts with A, B, C, right? In the calculator, they actually use A and they put it in the square brackets. And if you go to the calculator, I got to look at mine because I can't read it on there. It depends on the calculator that you're using. Where is it? Yeah. It's on the x to the minus 1. Unless you have an older calculator, an 83, and it has its own button, right? So if you've got an 83 in front of you, you'll notice that it has a button that says matrix. It's not something you get to by doing second x to the minus 1. So you should know where it is on the one you're using. So we're not going to include that as a step. We're just say go to the matrix, right? So if I go to the matrix here, right, above the x to the minus 1, second x to the minus 1, and there you can see how they're naming their matrices, A, B, C, and they put them all in square brackets, right? But one way or the other, it's capital letters. Capital letters for the name of the matrix, lowercase letters for the entries themselves. This is too easy, right? Now, for matrices to be equal to each other, then all the corresponding entries have to be equal to each other, right? So in these here, if you had to solve for the x and the y, you know that if this matrix is clearly written that it's equal to this matrix, then what is the value of x? Then you would have to say that the x equals -4 and the y equals 22. Right? In the second one, x equals 13 and the y equals 12. Now, when you get down to the last couple, they're a little more complicated than that. There might be a little bit of solving to do, right? Like in this one here, I mean, you could see the 16 and the 4, they match up. But the next one you'll have to solve. 2x plus 1 equals 5. Solve for x. Right? But that's the principle. Corresponding entries must be equal. And what does that tell you about if matrices are equal? What do you know about their orders? They got to be the same, right? Because you wouldn't have corresponding entries if they had different orders, right? So again, this is coming from section 8.2. It's not really an operation with matrices, but it's just trying to make the point. Matrices are equal because all the things inside them are equal to each other. Now, addition of matrices, right? You're going to add, if I'm adding these two matrices here, right? First, they got to have the same order. Second, you add the corresponding entries. So if I want to add this matrix plus this matrix. First, I got to add for the first row, first column. I add the first row, first column to the first row, first column. -1 plus 1. That's that. Then for the first row, second column, 2 plus 3, 2 plus 3. You know, it's pretty straightforward. In the end, we're going to get this matrix, 0, 5, -1, 3. Just add the corresponding entries. If I didn't tell you how to do this, you would have guessed that's probably what you're going to do, and you'd be right. The second one, I mean, the second one's all zeros. So what do you think you're going to get? The same matrix back again. We have something about that later. This is actually called the zero matrix, right? That's the zero. And usually if you, the zero matrix could be written like a matrix with, you know, square brackets with a 0 inside, something like that. So adding, subtracting would be the same thing. Adding, subtracting. They're not another slide for subtracting. It's the same thing. Okay, now, so adding and subtracting of matrices, those are considered basic operations, right? Given these two matrices here, right, we're defining A and B, and we're going to do these three operations, right? The first one says multiply A times 3. Okay, so that would say 3A is 3 times the matrix 2, 2, 4, -3, 0, -1, 2, 1, 2. And how would you guess that you do that? You multiply every entry by 3, right? So let's do that. 3 times 2, so 6, 6, 12, -9, 0, -3, 2, 6, 3, 6. I mean, you could think of it like a distributive property. When you multiply matrices by a constant like that, that is called scalar multiplication. Scalar multiplication is when you multiply by a constant. Right. Right. 3 itself is considered the scalar. A scalar means just a number. It's like a 1-by-1 matrix, right? It's just one number. When you've got more than one row or column, that's a matrix. So you have scalars, you have matrices. That is a common word in math. You're supposed to know what a scalar is. A scalar is just one number, a constant. Right, the next one, -b, I mean, that's another scalar multiplication, right? That's multiplying the matrix by what? -1. Right? And you probably wouldn't even show it like that, right? You're just going to put a negative on everything. But I'll write it like a scalar multiplication. 2, 0, 0, 1, -4, 3, -1, 3, 2. Right, so everything inside gets multiplied by -1, so they all flip signs. -2, 0, 0. -1, 4, -3. 1, -3, -2. What would we get if we added those two? You'd get the zero matrix, right? I don't see that they mention this in here, but sometimes that would be called the additive inverse, right? Because you add it, you get back to zeros. The next one, oh, and one other thing to mention here. There is no scalar division, right? There is no scalar division. But that'll come up in a later slide. We'll see that. You know, if you try to, well, we'll just see how that works. I mean, could you do scalar division? Sure, why not? You know, I mean, with a calculator, it won't take scalar division. So this last one, 3a minus b, right? That's some combination of scalar multiplication and subtracting of matrices. So let me do it here. Let me check what my next slide is. No. So 3 times a, 3 times 2, 2, 4, negative 3, 0, negative 1, 2, 1, 2, minus 2, 0, 0, 1, negative 4, 3, and negative 1, 3, 2. Now, notice that the orders of all these things are still the same, right? They have to be the same. Mason, you awake there? So let's do this math, right? 3 times 2 is 6, minus 2 is 4. 3 times 2 is 6 minus 0. 3 times 4 is 12. Negative 9 minus 1 is negative 10. 0 minus negative 4 is 4. Yeah. Where? Here? Here? That's a 6. Okay. Negative 3 minus 3 is negative 6. And 6 minus negative 1 is 7. 3 minus 3 is 0. And 6 minus 2 is 4. Right? That's not an unusual amount of calculating to have to do by hand, right? But we will get to, by the end of this lesson, things that you probably don't want to be doing by hand. So I'm going to start now by showing you how you can actually do this in the calculator. And you probably want to be following along. So things like, how do you, and put a matrix in the calculator, we know that part, right? So let's do this one in the calculator just to show how this works. So from this, let's say you get your calculator, you're on the screen here, and you want to put the matrix A in the calculator as it is right there. So first, go to matrix, however you go there, depending on your calculator. Second, x to the minus 1. And then you have to edit. So scroll over to the right and edit. And we want the first one, which is A. So I hit 1. Now, it's asking us for the order of the matrix. What is the order of our matrix? So it's 3, enter, 3, enter. And notice now it populates a 3 by 3 matrix with zeros. Okay, now we're going to write over the top 2, 2, 4, negative 3, 0, negative 1, 2, 1, 2. Every time you have to hit enter. Right? So 2, enter. And it moves you across the row. 2, enter. 4, enter. Negative 3, enter. 0, enter. Negative 1, enter. 2, 1, 2. Okay. So you should get to that point right there. Okay, then we got to do the B. Right, so go back to the matrix button, right, however you get there. Second, x to the minus 1, go over to edit, and this time select 2 for the B matrix. Right, put in the order 3 by 3, and then fill in all those right over the zeros with the actual B. 2, 0, 0, 1, -4, 3, -1, 3, 2. Are we okay? Anybody who's trying is getting it? If you're not trying, that's not my problem. Okay. Okay, so once you've got the A and the B matrix in there, right, we want to do 3A minus B. Go back to the main screen. Second quit, right? And now we're going to type in 3, right? And now go back to matrix, second x to the -1, and now just pick 1 for A, right? It puts on the A matrix next to the 3, minus second x to the -1, 2 for B, right? So you just put it in the calculator like that, 3A minus B. You okay with that? Right? Once you got that and you hit enter, it makes your matrix for you. So out of that exercise, at the very least, you should know where do you put matrices in the calculator? How do you like put them on the screen there to do an operation with them? Like these are operations that, you know, we would have done pretty well by hand, even if we had to, right? But knowing this, you know, there should never be a reason to get them wrong. Okay. Okay, so additive identities. So if we're just dealing with scalars, if I said 4 plus some number equals 4, what number would it be? It would be 0, right? And when it comes to matrices, if I had a matrix plus another matrix and I get this first matrix back again, then what must be populating all of those entries? Zeros, right? And that is called the zero matrix. Okay. Let's get to it. See. Where's their zero matrix? Yeah, in the book, they just have like a big capital letter like that. It looks like a capital letter O for the zero matrix. That makes it a little unclear. You know, what if that's just the letter O because you got that many matrices? Okay. You know, I think what this brings up more than anything is that we will be doing math now with matrices pretty much the same way we do it with real numbers. So on the left, this is the kind of equation that you would be asked to solve with real numbers, right? X plus A equals B, solve for X, right? And you would do what? Subtract A. I mean, they use 3 lines to do it, but in the end, they get X equals B minus A. Okay, well, we do the same thing. If these were all matrices denoted by the capital letters, right? X plus A equals B, it would work exactly the same way. In the end, the capital letter X matrix equals the B matrix minus the A matrix. You know, and you're doing pretty the same operations to get from here to here. Okay, so let's see this one. This is our matrix equation, right? Right here, matrix equation. Okay, so we want to solve it like we did on the last slide, right? So this would start out with 2x minus A equals B. Solve for X. What would the next line look like? 2x equals A plus B, right? And then what? Okay, so you could go x equals a plus b divided by 2. So, I mean, definitely if we're doing this with matrices, right, the a plus b equals 6 plus 4 is 10, right? 1 plus negative 1 is 0. 0 plus negative 2 is negative 2. 3 plus 5 is 8. A plus b over 2 would be 5, 0, negative 1, 4. Now let's go back and do that with the calculator, okay, and see how that works. But I'm going to store I have to store a new matrix for A and a new matrix for B, and then I'll come back to the main screen and try to do A plus B divided by 2. Second, x to the minus 1, edit. Again, edit is where you go. It's a 2 by 2 this time. 6, 1, 0, 3. That looks good. Then I go back, second, x to the minus 1, edit, 2. 2 for B is a 2 by 2. 4, negative 1, negative 2, and 5. Does that look good? Looks good. So now I go back to the main screen, and I want to do A plus B divided by 2. I'm going to use parentheses here. Matrix 1 plus matrix 2 and parenthesis divided by 2. And what do you get? You get an error, right? Now try it again. 1. This time, instead of doing division, multiply it by half. Right? How about this time I'm going to go 0.5 parentheses matrix 1 plus matrix 2. And there it does it. Okay, so that's what I'm saying. That, I mean, yeah, you can divide a matrix, right, if you're just doing it by hand. If you're using the calculator to do these kinds of things, it doesn't do division. You have to multiply by the fraction, 1/2, right, and then it'll work. Okay. Let's see. I don't have too many more slides here. Okay, now, matrix multiplication is not scalar multiplication, right? Matrix multiplication is multiplying a matrix by another matrix. And while most everything we just did was kind of intuitive, you would have guessed it if I didn't tell you how to do it. This one is not. Right? Okay, so I mean, I think if you look in the book, you could see they're, you know, doing it all with letters and subscripts and things like that, which I think you would find more confusing than just bring up a real example and try to do it. So let's see. Here we're multiplying these two matrices together, right? This is the A and this is the B. And notice the operation. When I want to fill in the first row, first column, then I use the first row, and I think I got that wrong, do I? That's N3, and that's negative. No, that's right. Use the first row and the first column. So, and it's kind of like patting your head and rubbing your tummy, right? You got to go like across one and down the other at the same time. -1 times -3 plus 3 times -4. Right, that's what this is right here. -1 times -3 plus 3 times -4. Yeah, you can simplify all that. That'll be 3 minus 12, negative 9. Okay. To fill the first row, second column, use the first row and the second column and do the same thing, right? You multiply the negative 1 times 2 plus 3 times 1. Negative 1 times 2 plus 3 times 1. That's negative 2 plus 3, 1. Yeah. No, we'll get to that. Okay, let's do now we want to fill the second row, first column. Second row, first column. So use the second row, first column, and do the same thing. 4 times negative 3 plus negative 2 times negative 4. That's this. Negative 12 plus 8, negative 4. Right, to fill the second row, second column, you use the second row and the second column. 4 times 2 plus negative 2 times 1, 6. Right, last row. Third row, first column. Use the third row of the first matrix, the first column of the second matrix. 5 times negative 3 plus 0 times negative 4, negative 15. And the last, third row, second column. Use the third row and the second column. 5 times 2 plus 0 times 1, 10. Now, question is always, well, why do we do that? Well, when we get to the next step of using matrices to solve equations, you'll see why this is exactly the way it has to be in order to make these things useful for what we use them for. Okay. Now, like I said, this kind of thing, I think is probably, and all the stuff we did up to then, I would say 90% of you would get right. You would get all those calculations right. You're going to start getting more of these things wrong. And even the rows and columns thing might get more tricky. But you put that in the calculator, it's done automatically every time. I mean, I'll do this one real quick, just to show you. Like, what do you have to do on the screen here, too? Let's see. Remember, how do I store a matrix? Second, x to the minus 1, edit. Okay, what's my first matrix? The order is 3 by 2, right? 3 rows, 2 columns. So we're going to go 1, 3, enter, 2, enter, negative 1, enter, 3, enter, 4, enter, negative 2, enter, 5, enter, 0, enter. All right, there's my A matrix. Now we've got to put in the B matrix, second x to the minus 1, edit, 2. And this one is a 2 by 2. So enter, enter. Now I need negative 3, 2, negative 4. That didn't go. Negative 4 and 1. Okay, now back to the main screen. I want to show matrix multiplication. All I have to do is second matrix 1, second matrix 2. I mean, you don't have to put a multiply symbol between them, just like other multiplication. You just write it right next to each other. It'll do it for you. So all that rows and column stuff. I mean, before we had the calculators, that was a really big deal. I mean, we sweated bullets over that, getting that right. Now, I mean, you have a way to get it right. So make sure you get it right. Okay. So multiply those two together. See if I was going to say do it by hand. Try to do it by hand first. See what you get. So I only have two more sides. And I give you the answer right here. I'll show you the work if after a few minutes you're not getting it. Remember, you just got to keep thinking like this. This times this times this. There's first row, first column. First row, second. This times this times this. This times this times this. This times this. How many got this? Got that? No problem. You don't need no calculator. Who needs a stinking calculator? But that's the math that should have been in there. Again, it's just kind of like that and like that. It's one of those things. In the textbook. I mean, I did copy from the textbook. Their PDF file, anyways. And so I've actually captured all the colors and things like that. I mean, a lot of times it's this, synthetic division, things like that. I mean, it's worth looking at their examples to see how they did all that stuff. Now notice about the orders of these things. I mean, Pierce just asked the question, but here's where it comes up. What is the order of the first matrix? 2 by 3. And what is the order of the second matrix? 3 by 2. So what is it that has to be the same in order to multiply these things? Remember the operation we're going through here, right? We're multiplying across the row and down the column, across the columns and down the row. Across the columns of the first matrix, down the row of the second matrix. What would you do if they didn't have the same number of columns in this matrix and rows in this matrix? It wouldn't work. So when you multiply matrices, what has to be equal are these two numbers. Right? As long as those two are the same, the number of columns in the first matrix matches the number of rows in the second matrix, then you can do the math. You can do it. If those don't match, then it doesn't exist. So these must match. Okay, so before we get to that, what's the order of our answer? 2 by 2. So you notice the 2 by 2 up here, right? Yeah, these have to match. These become the order of the result. 2 by 2. Order of the product. So notice these orders here, right? And this one, 2 by 2 times a 2 by 2. I mean, you would just assume you could do that as long as they got the same order, they should work. Although that's not necessarily true. But these match, So the answer is a 2 by 2 matrix. Right? Notice this one here. 3 by 3 times a 3 by 1. Can you multiply them? Sure, these match, and the result is 3 by 1. Okay? But what if I switch the order of those? What if instead I tried to do 1, 2, negative 3 times 6, 2, 0, 3, negative 1, 2, 1, 4, 6. Now I've got my 3 by 1 and a 3 by 3. These don't match, right? Don't match. So you can't do the math, right? Which tells you what? Order is important, right? A times B does not necessarily equal B times A when it comes to matrices, because the orders could be different, right? The way you switch them around is going to make it a different result. So AB not equal to BA. So which property would that be? If it works, you call that. What's the property that says order is not important? Commutative. Right? So that's definitely matrix multiplication is not commutative. Okay. I think I got one more. So what would you say about this multiplication? A times B, right? Don't match. And I think just to make sure, when they get one like that, what do they say? They say is not defined. Those are the words they use when it's the wrong orders. Not defined. Matrix multiplication is not defined for these two. Okay. That was it. So the homework is there. I think it'll be relatively easy.